In this video, we will cover the new features and enhancements in Genian NAC version 5037. To begin, we have expanded our security automation certifications to include B-Secure and Palo Alto Cortex XSOAR. Now you can leverage the vulnerability assessment and threat detection capabilities of these systems and integrate it with Genian NAC to perform real-time Layer 2 quarantine or traffic filtering based on the results of the scans. Agent log retrieval from the policy server web UI has been added. This is a huge time saver for administrators who would typically have to request the agent log from an end user or manually retrieve it. No group condition based on endpoint software version has also been added. This is a very powerful feature that allows administrators to group systems together based on the specific version of any software running on the endpoint. A Windows boot configuration detection has been added via the Agent plugin. This allows administrators to detect systems that are on the network configured with a multi-OS boot configuration and either notify or prohibit this type of configuration depending on policy. And finally, ARP enforcement control options have been enhanced to provide administrators more granular control over what traffic is ARP enforced based on the local or remote destination of the packets inside of the traffic. Palo Alto Cortex XSOAR provides world-class SOAR capabilities and is among some of the most recognized names when it comes to SOAR technology. B-Secure is a vulnerability assessment and management solution. The benefit of this solution includes continual scan for applications and vulnerabilities, the detection of 99.99% of vulnerabilities, flexible reporting to empower remediation teams, and complete organizational control. Genian NAC can now integrate with both of these platforms. From the main documentation page, search for integrating, and various integration hyperlinks will show up. We'll start with the Cortex XSOAR. Inside of this document, you'll find information regarding how the integration works. The overall process for this integration is that the Cortex XSOAR detects a suspicious node. It sends the node IP to Genian NAC. Genian NAC will check to see if the node is found inside the node database. If the node is found, it will validate the node ID, and then a tag is applied which can be used to either quarantine or restrict access. All of the prerequisites and all the configuration steps for both XSOAR and for Genian NAC are listed inside of this document, including testing and validation steps. There's also an integration document for B-Secure. The process for B-Secure: Genian NAC detects a new node on the network. It identifies a target for vulnerability assessment. Genian NAC then sends the request to B-Secure for vulnerability assessment. B-Secure performs a vulnerability assessment on the node. If a vulnerability is found, B-Secure sends an alert back to Genian NAC. Genian NAC then applies a tag to the vulnerable node, and this can be used for either traffic restriction or quarantine. Again, all the prerequisites and configurations for both B-Secure and for Genian NAC are actually listed in the document, along with testing and validation procedures. Now let's take a look at a visual depiction of how this works in the overall security ecosystem. This diagram will be used to depict the operational functionality and benefits of security automation between Genian NAC and external systems. we begin with a review of the components. The policy server can be hosted on-prem or in the Genian's cloud and is also available on the AWS Marketplace. Genian NAC network sensors are distributed across the network at the appropriate location to perform enforcement. There is typically a next-gen firewall and/or IDS SIM on the network monitoring for threats and vulnerabilities. As these systems detect either vulnerabilities or threats, notifications can be sent to Genian NAC using options such as syslog or API. The Genian NAC policy server then will instruct the sensors to perform enforcement on the network. The sensors then perform real-time Layer 2 ARP enforcement. This will quarantine devices on the network and prevent them from communicating with any other devices, even on the same wired or wireless network segment. Notifications can also be sent in real time from the Genian NAC policy server to external systems. Examples include email or SMS alerts to administrators, or notifications can be posted to external collaboration systems such as Team and Slack, or even to ticketing systems or other systems such as ServiceNow. This makes the Genian NAC security automation integration with external systems an integral part of the overall security ecosystem. Here we will demonstrate how to obtain the agent log by retrieving it through the policy server web UI instead of having to manually obtain it from the endpoint. From the main dashboard, click on Management and then Node. Locate the node for which you would like to obtain the agent log from. In this case, we'll be obtaining the log from the 192.168.1.252 node, which has an active agent as indicated here. Click on the IP to view the node details. In the right-hand corner, click on Node Tasks. From there, click on Collect Agent Logs. You'll get a note indicating it was successful. To obtain the logs, click on System. Navigate down to Debug Logs. Expand the System folder. Expand the Agent folder. And then expand the folder for the IP you collected the log from. Here you'll find all the logs collected from the agent. That's the current timestamp. If you click on the log, you can then download it. If you open the log, you'll see all the files inside of the log, including the current timestamp, which is the last update of the log itself. This feature is a huge time saver for administrators as it allows them to obtain agent logs from any endpoint on the network regardless of where it is connected, without having to communicate with an end user or anyone else to obtain the log. It can be obtained straight through the policy server UI. In this video, we will be demonstrating how to create a node group and an enforcement policy for an endpoint running a particular version of software. Any software running on the endpoint that is detected by the agent is eligible for the node group condition based on version. So here we have the main dashboard of our test system. If we navigate to Management and then Node, we see here a list of nodes that are active on the network. The test node that we'll be using today is the 192.168.1.252 node. And as you can see, there is an agent currently installed and running on this node. The application we will be testing with today is Google Chrome. So we'll be creating a node group for devices running a particular version of Chrome, as well as a node group for devices running less than that particular version, which will be our desired version of Google Chrome. So on the test machine, we'll go ahead and verify the Google Chrome version. We'll copy this to use it. And again, this will be our desired version of Chrome that should be running on any nodes on the network. To create a node group, we will navigate to Policy, click on Group. You can see here that there are presently no node groups referencing Chrome. To create a new group, click on Tasks, Create, give the group a name, now we will add the condition. Software version is equal to, we click Assign, locate Chrome, and there of course is the version that was already detected by the agent. Click Add, click Add again, and there we see the criteria, the operator is equal to, and the desired version. We'll click Save, and we'll go ahead and create a inverse group which includes devices that are actually not running that version. So I'll go ahead and copy this, create one additional group, less than. We'll go ahead and add a new condition. Version is less than, and we'll go ahead and assign the Google Chrome version we previously assigned. Add, add. So this node group will match on any nodes that are running a version less than the desired version. I'll click Save. And here are the two new node groups that we created. So I'm going to click Apply. Now these are active. And we can see there's already two matches here. So the desired version of Chrome, if I click on the two nodes that are matched, one of those is the test machine that we are on presently. I click on the IP of this machine, and we'll see all the information that the agent is gathering: motherboard, memory, disk, OS, network connections, IPv4 6 configurations, sharing, USB devices, account information, boot configuration, printers, etc. So a lot of information there. If we click on the Software tab, we're going to see all of the software installed on the endpoint. So what we're going to do in this list is we're going to actually locate Chrome, which of course you see here is the desired version. So we know that this machine is running the desired version, and it also matched on the node group. So for devices that are not running the appropriate version, we're going to create an enforcement policy. So any devices that come on the network after we create these policies will automatically be assigned the appropriate privileges based on that policy. So just to recap, if we look at policy and group, and we type in Chrome, we have the two groups that were created, one for the desired version of Chrome, the other for the less than the desired version of Chrome. Presently no nodes are matching on the second group, but we want to set this up so if any new nodes do match on this after we create these groups and policies, that they are handled accordingly. So what we will do is we will now create an enforcement policy to match on the node group. To do that, we click on Policy, Enforcement Policy, and we will create a new enforcement policy using the wizard. So we're going to call this Internet only for devices with Chrome less than. Okay. Click Next. Here you can actually see all of the node groups that are in the system, including the ones we just created. So we will match on any nodes that are in the devices running Google Chrome version less than the desired version. Next. Here we can assign whatever kind of permissions we want to assign. So we're going to go ahead and just do Internet only. You could block these devices. You could assign them specific privileges, very granular permissions, but for the purposes of this test, we will just assign Internet only permissions. If you were going to quarantine the devices, which is a little strict for this policy, you could put a captive portal page in front and then have a detailed message here indicating maybe you're running an unauthorized version of Chrome, call the help desk, or something to that effect. You could also do other methods of enforcement. The Genian NAC default method of enforcement is ARP enforcement, which does not require any network integration, and all the permissions are assigned in software. But you could also enforce via SNMP or radius as well, and assign various radius attributes based on the status of the endpoint. But for the purposes of this test, we'll go ahead and just leave ARP enforcement, and we'll finish. So now you can see here's what the policy group looks like. We're matching on the node group for any nodes that are running less than the desired version of Chrome. And we're giving Internet only access, which means we're excluding access to the internal managed networks, and that is what the enforcement policy entails. If I click Apply, here's a quick review, and now the policy is active. So presently no nodes match on that, which is great because we actually do not want to, because we expect that there are no nodes that are actually running that version. But if any devices connect to the network subsequent to this policy being created, they will be assigned Internet only access, and that way they cannot compromise any of the internal networks. And again, just a reminder, these permissions are all defined in the Genian NAC software, and these follow endpoints if they move across the network from wired or wireless, one building to another, one site to another. There's no dependency on any network integration to enforce these policies. Next, we will cover an improvement to Genian NAC ARP enforcement, which gives administrators more control and granularity over how ARP enforcement functions. To review, we will take a look at the sensor settings relative to ARP enforcement. Click on System, Sensor, select the sensor, and under Tasks, we are going to view Network Sensor Settings. Here, we'll take a look at several settings. We're in enforcement mode, which means we are enforcing using ARP enforcement. And the two relative settings here for discussion are the local net control and the remote network control. Both are enabled by default. This means when a device is being ARP enforced, that all local MAC addresses as well as the default gateway are going to be enforced and resolved to the sensor MAC address. Any traffic destined to devices on the same segment or devices on a different network segment will be filtered through the network sensor. To demonstrate this, we have a test set up. So here we have a ping going to a Google DNS server, which is off the local network of the test machine. And here we have a ping going to a node that is on the same network segment. Here's the machine .252 we're testing on, and here are the relative ARP entries. So the default gateway, the sensor, and the node that is on the same segment all have their own unique MAC addresses inside the ARP table. Next, we're actually going to block the node using ARP enforcement. So we're going to select the .252 test node. Under tasks, IP and MAC policy, we will deny the MAC. So, with the MAC address denied, what you're going to see is the pings failing both for the Google DNS server, which is through the default gateway, in other words, on a remote network, and you'll also see the pings failing now for the .157 node, which is on the same network. Now remember, previously the ARP table had unique MAC addresses for all these nodes. If I refresh, now you'll see that the sensor MAC address is the MAC address for both the default gateway as well as for the .157 node, which is on the same network. So this is the default mode of operation where both local same segment nodes and the default gateway node ARP poisoning occurs for both. And the new feature gives more granularity for administrators to change this behavior, which we will cover next. So what we'll do is we'll go ahead and unblock this node. We can just select the node from the node list, go back to IP MAC policy, and allow the MAC, which will unblock the node. Now you see both pings returning for the Google DNS server and the node that is on the same network segment. The ARP table is back to normal with everything having its own unique MAC address. Now what we'll do is change the behavior. Under System, Sensor, we'll select the sensor, and then we will edit the network settings. Under the network sensor settings and under enforcement, you'll see here the local network control, which will enforce for devices on the same network segment, and remote network control, which will do ARP enforcement for the default gateway. So what we're going to do for this test is we're actually going to turn off the local network control for traffic that is destined for nodes on the same network segment and leave the remote control on. You could, of course, reverse this, and this is the enhancement to be able to have more granularity over what traffic is ARP enforced and what is not. So we'll go ahead and apply this. Now we'll go back to our node list, and of course we had unblocked this node, so traffic is pinging successfully now, and the ARP table is normal. We'll go ahead and block it again. IP MAC policy, deny MAC, and we will go revisit our pings and ARP table. So now you'll see the behavior is a little different. We opted to not ARP enforce on traffic destined to nodes on the same network, so the 157 ping is still replying. However, remote network traffic is being enforced, and that's why the Google DNS is failing. And if we refresh the ARP table, of course here's the normal ARP table. Now you see that the ARP enforcement is only occurring for the default gateway's MAC address, which resolves to the sensor. However, local segment MAC addresses are not altered, and that traffic will be able to reach the hosts unimpeded. And of course, as mentioned, you can actually configure the reverse, so you may have different reasons for wanting to change your ARP enforcement behavior, but with the new addition to the settings, this allows administrators the most control. And of course, one more reminder that ARP enforcement requires no integration with the network and has no network dependencies whatsoever.